Right. Hi everyone, thanks for coming to my talk. Today I'm going to tell you how to value actions in soccer. So why do we want to do this? This is actually a really important task in the research field of soccer analytics. So we want to know the value of different kinds of actions on the field. So like examples of actions are shots or passes or dribbles. So what's the problem with the way this is currently done? Well, the existing work values usually only a single type of action. So they either focus exclusively on shots or focus exclusively on passes. They don't handle all the different types of actions on the field at the same time. So most work actually focuses on shots, but if you only focus on shots, then what we see is that you're basically ignoring 98% of your data. So our idea was, why don't we try to value all on-the-ball actions and try to use 100% of our data. So as a quick outline of this talk, there are basically two big challenges to do this, and then I'll go over some applications in player scouting. So the first challenge is that real-world action sequences are messy. So I know no data set is perfect, but really soccer data is like its own special kind of hell to work with. Like for example, you can have many missing or unrecorded actions. So the way this data is recorded, like many companies have like a small army of human annotators that write down everything that happens on the pitch. But humans are not perfect. Sometimes they miss things. Or even some companies make the decision to just consistently not record something. Like there are companies that don't record dribbles for some reason, even though that's really useful information. So, but then they do maybe record some pretty useless things you don't care about, like weather changes. Like usually when you're trying to value actions or players, you don't really care whether it starts raining or not. And then one of the really big problems with working with this kind of data is that there are multiple companies that sell this data, but they all have their own specific terminology. So what this means is that if you write like a script to work with one company's data, that script is totally useless if you want to work with some other company's data. That's a big problem. Then the final challenge is that actually also these companies all include some extra information on their actions or events. And then the problem there is that, basically whenever you get an action, you're not quite sure what its attributes are going to be. So that's also really hard to work with. So we come up with a solution for this, which we call Spaddle. And it's kind of like a layer on top of these existing actions. On top of this existing data. And it's supposed to be really simple and human interpretable. So we sat down with some soccer experts to design this language. And our contribution to the soccer analytics community is that we have converters to this more simple format freely available online. So what makes it really easy to work with is that you only have the same attributes per action. So you can just represent this data in a table. That makes it way easier to work with. So now we've got most of the data challenges solved. So the second challenge for valuing actions in soccer is that most actions actually do not really affect the score. So a soccer game contains about 1,600 actions on average. And so here they are, all visualized. And like the most common final score in soccer is actually 1-0. So that means one of these 1,600 actions caused a goal, and the others did not. So how do you go about valuing those other actions if you're not sure, like, was this a good action, was this a bad action? So this low-scoring nature of soccer makes it so that valuing an action or finding like how good a player is they're really high-level questions with no real objective ground truth. So that makes it quite hard to answer this question, actually. And it's my opinion that the low-scoring nature of soccer is what makes soccer analytics even harder than in other sports like basketball and baseball. So here's an example of an action, a pass from Messi to Busquets. So, okay, here's a pass. Was this a good pass? Was this a bad pass? Well, we have no idea. It didn't really, you don't know whether it helped cause a goal or not, so you don't know whether it was a good action. So it didn't cause a goal, but this action did do something. And what it did is it moved the game from one game state to another. And that is something that we can work with. So our second contribution is that we offer a framework to value an action by its expected impact on the score. So not its real impact, but its expected impact. So what exactly do we mean by this? Well, the intuition is that a good action should probably increase your short-term probability of scoring or decrease the short-term probability of conceding. Conceding is when when your opponent is scoring a goal. And our framework, our formula, is basically just this intuition captured, in some symbols. So this says here that like the vape value, which is the name of our framework of an action, is the delta of scoring minus the delta of conceding. And the delta of scoring is just the difference between the probability of scoring in the game state before the action with the probability of scoring in the game state after the action. So this might seem like a pretty simple idea and a pretty simple formula, but it's actually really powerful because what it allows us to do is to go from a subjective task, like valuing an action, to an objective machine learning task that you can train a classifier for and you can like measure how well you're doing on this. So now our job goes from valuing actions to just estimating probabilities. So this is our machine learning task, estimating the probabilities. And in any machine learning problem, you have basically 3 ingredients. You have your features, your labels, and a classifier to solve it. Now I'll just quickly go over these 3 ingredients. So the first ingredient, you need features that describe the current game state you're in. Well, luckily, we have this great language that is already really informative of what the current game state is like. But then, you might want to have some extra information. So then we also have some more complicated features, like the distance to the goal, which is really useful because the closer you get to the goal, it's probably more likely that you're gonna score. And also the time difference between consecutive actions kind of tells you a bit about the speed of play, like whether it's like more of a build-up or more of a counter-attack. Then finally, we also include some context features like the goal difference, because it's obvious that ahead or 2-0 behind, they're gonna play differently and they're gonna do different types of actions. Okay, so that's the features that describe the game state covered. Now we need labels, and we need labels that capture the limited temporal influence of a game state. So what exactly do I mean by a limited temporal influence? If you look at 2 different game states and you have a certain game state and then a pass occurs and then immediately a goal is scored, then you can say that there's probably some relation, some influence between that game state and a goal. But on the other hand, if you have a game state and then 10 minutes later a goal occurs, then that initial game state probably had nothing to do with that goal occurring. So you need labels that kind of capture this delicate balance. So our solution to this is that we label game state as positive, as being responsible for a goal occurring, if a goal occurs in the next 10 actions. And the same thing for conceding. So that's our answer to this problem. So okay, now we have our features, we have our labels. All that's left to do is decide on which classifier to do. So we just used a couple of popular classifiers for probabilistic predictions. So cat boost, XG boost, logistic regression, and random forest. And we evaluated them on 2 different metrics: the Brier score and the area under the ROC curve. Brier score is really important because it measures the accuracy and calibration of our predictions. And since we're summing and subtracting probabilities, it's important that these probabilities are well calibrated. And area under the curve, because it works well for unbalanced data sets, which we're clearly dealing with a very unbalanced data sets. So we see that cat boost is actually the winner, but only by a very narrow margin. XG boost is a very close second. So that's basically it. Those are 3 ingredients that we use to solve this machine learning task. But our task wasn't to estimate the probability of scoring and conceding. Our task was to value on-the-ball actions. Well, you just use the probabilities generated by these first 3 ingredients. You plug them into our formula, and now we have everything we need to value actions. So now some intuition as to how these action values actually look like. So this is an example for this. Barcelona is going to score a goal against Real Madrid. So this is Busquets passing to Messi, but it's pretty neutral. It doesn't really raise the odds of scoring that much. Here Messi passes past Busquets. He actually moves the ball further away from the goal, so it gets rated negatively. But then here it gets interesting. Like this is a pretty good pass, and this actually helps raise the scoring odds by 1%. This dribble is really great, and it gets a really high value because it really raises the odds of scoring. And then this backwards pass gets rated even higher because now the chances of scoring are 17%. And then Vidal actually turns it into a real goal, so he gets rewarded by 0.83, because he took a 17% chance of scoring and converted it into 100% chance of scoring. So he gets rewarded here a lot, but if he would have missed his shot, then we actually would have penalized his shot, with a rating of minus 0.17. So yeah, if you want to get high values, you should definitely score your goals. So this is so these are basically that was it for the methodology. I hope you have a sense of how our system works. So what can you actually do with these action values? Well, you can have a lot of fun with them, and there are a lot of applications in player scouting. So I'll briefly go over how to rate players using these action values and how you can identify top players and compare players on playing style. And then finally at the end, we'll answer the biggest question in soccer. So stay tuned for that. So just to have a quick look at what our data looks like. So we have data from the top 7 European competitions. So I'll briefly touch on the English, Spanish, and Dutch league. For these competitions, we have access to 5 seasons. So this makes about a bit more than 11,000 games and over 14 million actions. So the way we use this data is actually we trained our probabilistic classifier on the 4 seasons before 2017, 2018, and then the season 2017, 2018 was actually the season we then predicted the probabilities for and got the action values for. So all our use cases are of the 2017, 2018 season. So, okay, how do you rate players using our action values? So let's assume you have some money, you want to buy a player, you're not sure which one. So you're wondering, maybe I should buy Lukaku, or maybe I should buy Alexander-Arnold. So, but it's kind of hard to compare them, right? Because Lukaku is a striker and Alexander-Arnold is a defender. So, if you want to just measure how much will this player help me score goals or just help win matches, then it seems like a pretty obvious choice to pick Lukaku, because if you go for something like goals plus assists per 90 minutes, which by the way in the field of soccer analytics is already a pretty advanced metric, then you see that Lukaku is just, it would be a better choice. But what happens if you actually rate players on all their actions instead? So this is a graph that shows this. And so this graph shows the trade-off between a player's the quantity of his actions and the quality of his actions. So the quantity is just how many actions they do per game. So you can see Lukaku does about 30 of them and Alexander-Arnold does about 90 of them. Then the average action value is where our action values come into play, and it's just the average value of all the actions performed by that player. So what we can see here is that Lukaku, every time Lukaku touches the ball, your odds of scoring go up by roughly 1%. And then every time Alexander-Arnold touches the ball, your odds of scoring go up by roughly 0.5%. But actually, to get their total contribution to their team over a game, you have to multiply this. You have to multiply the average action value by how many actions that player actually performs. And so, this multiplication is what we call vapor ratings, which is the name of our framework. And here we see that actually, on average, we say that Alexander-Arnold, even though he's a defender, is more useful to your team to have than Lukaku. So if you ever get a choice between those two, you should pick Alexander-Arnold. Okay, so you can actually construct the same graph for basically any player that you have data about. So these are all the players in Spain and England in the 2017 and 2018 season. And so the green dots are attackers. So you can see they usually don't perform that many actions, but those actions usually get a really high value. While for defenders, it's then the complete opposite. So it's nice to see that you can really see the trade-off. Either you do a lot of actions, but then they're not going to be as valuable, or you don't do as many of them, and then hopefully they're really valuable. Okay, so you have our player ratings. So let's assume, okay, you're a club, you want to buy a good player. So then our algorithm spits out the 5 best players in the Premier League. So if you're somewhat familiar with soccer, hopefully you'll recognize some of these names. People agree that these are pretty good players. This is actually, and this passes what we call the eyeball test in soccer analytics. That's actually it sounds very informal, but it's actually a big part of soccer analytics because there's no real ground truth to work with. So you just kind of you construct these kind of rankings and you just see whether they make sense from a soccer domain expertise point of view. So, but if you want these players, there's one problem, which is they're pretty expensive. it's not a secret that these are good players. So let's see if we can do something different. Well, if you want to buy a cheap player, you have two options. You can look at younger players, as they tend to be more, less expensive. And you can also look at a different league, because players in Spain and England are really expensive, but players in like the minor leagues are usually a bit cheaper. So this is, these are 5 players that we concluded at the end of the 2017-2018 seasons. These are really good players, and they were still, they weren't that expensive. So yeah, the problem is if you want to buy these players right now, is that the world has caught up that these are actually really good players. And yeah, I think just Steven Bergwijn still plays for PSV. All the other ones have moved or are soon going to move to big clubs like Barcelona, Real Madrid, or probably Manchester United and Chelsea. So yeah, but still it's cool to see that we were actually kind of able to detect like that these are really good players, like ahead of when it became mainstream opinion that these were really good players. Okay. So another thing you can do with our ratings is look at playing style. So the question is, so Ronaldo, if you follow soccer somewhat, he left Ronaldo Ronaldo left Real Madrid last summer, but yeah, Real Madrid hasn't exactly had the best season since then. So now they bought Hazard as their new Galactico. So the question is, can he really replace them? Well, judging by their vape rating, turns out Hazard is a pretty good replacement for Ronaldo. But I mean, you can't capture like the entire contribution of a player in just one number. Like you need some more information. So another thing you can do is like look at how many actions they do per 90 minutes, which is somewhat informative. Like we see here that Ronaldo shoots more than Hazard and Hazard passes more than Ronaldo. So yeah, I mean, that's kind of general knowledge. So, but the interesting thing, what we can do is we can actually differentiate those types of actions based on how much value they create. So what we see here is that Ronaldo gets a lot of value from his shots, and like some value from his dribbles, and almost no value from his passes at all. While Hazard is a much more balanced player. Like he gets roughly as much value from his shots, dribbles, and passes. So yeah, I think this kind of like gives some insight into Ronaldo's thought process, where if he has the ball, he thinks, can I shoot it? Then if he can, he shoots it. If he can't shoot it, can I maybe dribble to a position where I can shoot it? And if he can't do that, then he's like, yeah, okay, I'm gonna pass. And then you see here that those passes are actually usually pretty crap. So yeah, okay. Now for the biggest question in soccer analytics. You probably know it. Who's better, Ronaldo or Messi? Raise your hand if you think Ronaldo's better. Okay. Raise your hand if you think Messi's better. Okay. I'm sensing. Some of you are going to be disappointed. You'll find out in a minute. So, if you remember this graph where I said that all players in Spain and England are on this graph, I actually lied. This graph contains all the players except Ronaldo and Messi. So let's start with Ronaldo. He's a striker, he's an attacker, so he's probably going to end up somewhere around here. And yeah, you'd be right. He's like one of the best attackers there. So he doesn't do that many actions, about 40 of them. But his actions are really valuable. So then Messi is also an attacker. So you think he's probably somewhere roughly in the same area. Messi is over here. He's a complete outlier. It's like, it's ridiculous. Like there's this trade-off between either you do a lot of actions or you do valuable actions. And that applies to any mortal man except Messi. He's like, yeah, it's just ridiculous. Like his actions are on average, like even a little bit more valuable than those of Ronaldo, but he actually does almost twice as much of them per match. So sorry, Ronaldo fans. It's, according to our system, actually, yeah, Messi is just completely ridiculous. It's actually a known fact within like soccer analytics that if you want to normalize your data, then you have to leave out Messi, because otherwise your normalization is completely screwed. It's like, he's just a complete anomaly. So yeah, if you want to use these action values, there are two options. So there are some, so basically a big contribution of our paper is actually that we put everything online for like the soccer analytics community to use. So it's a pip package that you can install and play with. And we also have some notebooks that demonstrate the full pipeline of our paper using some free StatsBomb data. It's not the data we use in the paper, but it's other data about the FIFA World Cup. And it just goes you through the full pipeline of like converting the data to our format and computing these action values and so on. But if you don't want to get your hands dirty, then actually our partner, SciSports, they have a platform called Insights, and they actually already offer all these player ratings and action values on their platform. So if you just want to look at some things, get in contact with them. So to wrap things up with some concluding thoughts, yeah, real-world soccer data is nothing like UCI datasets. There's a big mess. It's just incredibly frustrating to work with. You really need like months and months of digging in to start getting something useful out of it. And also a big challenge in soccer analytics that, yeah, I mean, I'm now here saying like these are really good players, and who's gonna prove me wrong, because there's like no real general agreement, right? There's no ground truth about what are good players, what are bad players. But nevertheless, we think that valuing all on-the-ball player actions captures some information that it goes ignored by existing soccer stats, like goals and assists. And yeah, it also has many use cases. So for example, in player scouting. And yeah, the final conclusion is also really important. So that was my talk, and I'm happy to answer any questions.